It's been a while since we have talked about inheritance, but now that we're up to talking about gender in humans, we need to revisit one last topic. Because unlike plants, people have sex chromosomes, and if you're male, those chromosomes don't match. So that means inheritance works just a little bit differently. Let's explore. Remember when we looked at genetics before, we talked about genotypes a lot, and we just symbolized those with letters. So that would be the heterozygous genotype with the dominant and recessive allele. And usually, when it comes to diseases, you want to avoid getting two recessive alleles. That usually wasn't a big deal because as long as you inherited a dominant allele, you were safe. Now, that's not the case if you're male and a mammal, because mammals determine gender mainly by this guy right here. If you get a Y chromosome, then you're male. Two X chromosomes means you're female. Actually, even if you have only one or even three X chromosomes, you can still be female. But those are weird exceptions. So let's just kind of focus on this one for now. The X chromosome, as you can see the picture here, has a lot more DNA and therefore a lot more information than the little tiny Y chromosome. So when we talk about sex-linked traits, we're really mainly talking about X-linked traits. There are some Y, but let's just focus on these for now. What this means is if you're female and you inherit a recessive allele, you can easily get a dominant allele to cover that up. So you might have the recessive allele here and the dominant allele at the same location on the other chromosome. However, if you're male and you inherit a recessive allele here, there's nothing over here as a backup, and so you get the disease. Oh, that's a jip. Guys are always getting the shaft. That's true, but women do have the pregnancy and childbirth thing. Yeah, that's fair. Well, it's also not that many diseases. There's just a few common ones, like color blindness, muscular dystrophy, and hemophilia, and they're still pretty rare, but still much more common in males than females because there's no backup copy. That's why it's good to have two copies of all those genes. It just doesn't happen in males. Well, in terms of how the inheritance works, it's really not all that different than what we've explored before. We just need to make a couple of shifts. All right, so let's go back to our basic genotype. Now, it could be that gene A was carried on chromosome number 3. But we didn't note that because we didn't really care, but we could have noted it kind of like this. On chromosome 3, you have a dominant A allele, and on the other chromosome 3, you had a recessive A allele. Just seems like a lot of extra writing that we didn't need. But I think you can probably see where I'm going over here is now instead of chromosome 3, we can note that if you're female, on that X chromosome, you carry a dominant allele, and on the other X chromosome, you carry a recessive allele. There are a variety of ways to note this. This is just one way. It's the kind of style that I like to use. And so a male might have a dominant allele on the X chromosome, and the Y is just blank. I mean, I guess we could use a 0 or some other placeholder, but this is kind of nice because we now know the gender of the offspring. We never knew the gender of the offspring in the old Punnett squares because it didn't matter. The probability was the same for every gender. But a lot of times in these sex-linked inheritance problems, you'll be asked to give probabilities separately for boys and girls in terms of the offspring. Let's try a practice problem. Well, here's a problem all set up for us, and we're asked two questions, one about the sons and one about the daughters. So we are being asked to answer separately for each of the kids. Question is about color blindness, which is a recessive allele, of course on the X chromosome. And so we have a woman and a man, and we're asked about their kids. So a pretty typical problem. let's follow the setup we did before, where we lay out all of the parts really carefully. So we'll figure out a legend, summarize the genotypes, and then make sure we answer the questions asked. And the questions are about who is likely to be colorblind, so it's really a question about the phenotype. And with that, we know that the dominant allele, well, it doesn't tell us what the dominant allele is, but we know that must be normal. In the case of diseases, that's usually the other option. But the recessive is colorblind. So there we go. And we also know, we might know that it's only carried on the X chromosome. Genotypes. All right, so the woman's genotype, she has 2 alleles. And we might even start by putting in the X chromosomes here. And she has normal vision. So that must mean that she has a dominant allele. And then her father was colorblind. Well, that's interesting information, but it doesn't exactly tell us what's going on here, but we can figure it out. We still don't know for absolutely certain what this allele is. You might know it, but let's work through it. If her father was colorblind, he had an X and a Y chromosome, and he must have had a recessive allele on that X chromosome. And the only thing he could have passed on to her is this X chromosome. If he passed on the Y, she would have been his son. So there is the genotype of the woman. All right. Well, what about the man? He has an X and a Y chromosome, and he is colorblind, so that one's easy enough. There are their genotypes. Okay. So we'll do a Punnett square. Works the same as before, and figure out what fraction are likely to be colorblind and separate it for sons and daughters. So there's our Punnett square. We're going to take the woman's up here. And I'm keeping the X's with them. Otherwise, I'm going to lose track of who is who and what is what and what gender everyone is. But everything else, this is carried on one gamete in the egg. And this one is carried in the sperm, and that fertilizes the egg, if you remember how the Punnett square works. So that's what we're doing here. All right, there's our Punnett square all done. And we're asked about the fraction of sons that are colorblind. If we're only asked about the sons, that's just going to be these right here. Got to have an X and a Y chromosome. And it looks like half of them would be colorblind, at least likely to be. What about daughters? That's these up here. That's actually also half. A bit of an unusual result. Usually it's far more likely that males would be colorblind than females. But when you look at the parents, that's not entirely surprising because there was a lot of recessive alleles going on in here. So that's how you work out the problem. Well, there's sex-linked inheritance problems. Not too hard, right? Just like any other ones, take your time, work out the details, and it should be fine. That's it for this time. Until next time, keep enjoying life.